So one problem sometimes when building your code, the errors don't come up the way that you think they are. You're unsure what's going wrong. If I'm coding strictly on a computer and something's not working, I know almost certainly that it's going to be a problem with the code because that's all that's going on. But here I have code and I have a circuit. So sometimes I'm unsure what's not working here. So if I press this button and this LED is not lighting up, but I think it should be lighting up as far as my code's written, did I write something wrong in my code? Or did I set up my circuit? I don't even know maybe if my button's working or not. So we need to do a little bit of debugging. And a very easy way to do this, and it's going to be the way that I expect you to start things out a lot of times. If you come by and you say it's not working, first thing I'm going to ask is, did you print anything? Now, when we talk about printing things in code, it doesn't mean hooking up a printer and having something come out in paper telling us what's happening. Instead, what it means is I'm going to have something come up onto this screen here, and it's going to tell me information. So first I'm going to show you some syntax, and then we're going to talk about a couple other ways to do it and exactly what's happening. So the first thing that I want to do is in the setup, I need to tell my microcontroller that you're going to have to be prepared to either send or receive information to the computer that you're hooked up to. And the way I'm going to do that is I'm going to type in the word serial, not like the food, but like the word meaning one after another, and it starts with a capital S, serial. I know most of the time things start lowercase. In this case, it starts uppercase, and then it's a dot, period, serial dot begin. I'm going to begin a serial connection, a connection where I'm going to be sending information consistently, one after another, through, and I need to put something in here, and I'm going to put the number 9600. And what that 9600 means is the speed at which this information is going to be sent. So I start this setup. Start a setup of information that's going to be sent in a serial fashion, one after another, at this speed. And again, I'm going to close this off with a semicolon. Now, anywhere after this in my code, and I can do this multiple times throughout my code, really anywhere that I want to do it, I can have it send to print to this screen any information that I want. I can have it print off text if I want, or I could have it print back a value. So let's start off with a value. First thing I need to do is I have to have a value to print. So I'm not going to print before I save anything because there's nothing to print. I'm going to go right after these variables, and I want to know, what does button state 1 equal? When I click this, does it change? Does it equal 1? Does it equal 0? What's happening? Does it actually change when I click it? Did I set something up right? So the syntax here is I'm going to write the word serial again, capital S, dot, then I'm going to write the word print, serial dot print. And then inside the parentheses here, I'm going to type anything. If I want it to come up with a word, I can just type a word out, but I need to put it in quotations. In this case, I want to know this value. So just like anywhere else, when I type in LEDR or button state 1, what it does, it looks back in memory to see what that is. If I tell it to print, what it's going to do is it's going to look back in memory, see what it is, and then it's going to send it to this screen for me to see. So, button state 1. I want to know what button state 1's value is. Now, when I run this, we'll be able to see some things. Real quick, I'm going to open up Arduino and show you a couple ways to open the serial monitor, the way to see this. So I can do the same thing in here, and then I can click this button over here. That will open the serial monitor so that I can see what's being printed. I can come up here to Tools and click here. That will open up my serial monitor. Or I could press the combination of Control, Shift, and M, and that will open up the serial monitor. That's what will work in this Arduino environment here, in the one that you download onto your hard drive. If I'm on the editor here, online. Where is it? I don't remember off the top of my head. Sketchbook. All right. Oh, there it is. Monitor. Serial ports are unavailable. I don't have anything plugged in right now. But that's what you'd plug in, and then this window would open up right here, and it would show you all the values that are coming up. And you'll see that it does have this right here, 9600. I hope that looks familiar. That's telling it the speed at which things are going to happen. There's this button called auto scroll, which will allow it to either stop scrolling down as it prints, or it will follow all the new things as it prints. I'll show you that in a second. Same thing here. If I am printing something, it'll tell me the speed at which I'm doing it. All right, so let's look at the simulator real quick. And I'm going to run this. And if I typed everything in good, okay, no errors. And in this case, to open the serial monitor, this one's at the bottom here, so I'm going to click this. And you'll see that it just has a whole line of zeros. And it's just going to keep going 0, 0, 0, 0, 0. If I click a button here, something should change, but I'm unsure what's going on because I have to keep scrolling over. You'll see that there are some ones now. Now it's back to zeros. So you'll see that it is recognizing the button, but it's doing some weird stuff. So what I'm going to do here is I'm going to stop my simulation, and I'm going to show you an easy change, something that I really like to do. And you'll see that as it prints this information, it just prints it one after another, after another, after another, and it can make it difficult. It's not so bad when you're just reading zeros and ones, but if I'm reading an analog number, something that's bigger than that, I don't necessarily know where my number is beginning and ending. Everything just kind of runs together the bigger the number gets. But if I do something really simple and I just write the number, or the letters, LN after print, that's not a 1, that's an L, that will print on a new line. So I'll show you what happens when I do this now. Start simulation. You'll see that now it prints up and down. Makes it a little bit easier to see, and you'll see that when I click the button, something changes. So my unpressed position is 0, my pressed is 1, and then I unclick 0, and if I do it quickly, you'll see it changes quickly. All right, so I know that button's working. Now if I want to do the second one, I could, if I wanted, just change that, right? Because now it's going to check button state 2. It's going to check my other button to see what's happening. So this one's also working. All right. Now, what if I want to see both buttons at the same time? I could put both of them in here. I forgot the dot. Serial.print ln button state 2. Now you'll see that only every other one's on because one button isn't pressed right now. And every other button's on because, well, only one's being pressed right now. But it's hard to tell which one because they're on top of each other. So I can kind of mix and match with this print ln and just a regular print. Let's see what happens if I do this. I take the ln off the first one and leave it on the other. Now it prints on next to each other because one of them prints without making a new line. The other one prints with making a new line. So you'll see that when I click this one, the first one turns on. What should happen when I click the other one? I'll let you take a quick guess. Now the other one's on. There you go. A couple other things, let's say that I don't want them right next to each other. I could put another serial.print in here. And in this case, I'm just going to put, like I said, you could type words in here. Characters, well, And a space is a character. It's an empty character. We don't see anything. But anytime I want to type a character in, I just put it in between quotation marks. What this will do is, after it prints this value, it will print 2 blank spaces, and then it will print this value, and then it will make a new line and do it again. So now, instead of these being right next to each other, there's going to be a gap between them. It's going to make it a little bit easier to see, especially if I'm using other numbers besides just 0 and 1. I could go a little bit further with this, and above here, I could type in another word. I could say, my button states. Let's say that I'm doing multiple ones of these. I have maybe a potentiometer or a photoresistor or buttons, and I have other things that I want to print. As this is printing and I want to know what's happening, I could label things with words. So now you'll see that it says my button states. So it does make it kind of nice and easy to read. This is one way to debug things, to know exactly what's happening. I'm going to show you one other thing that I can do, and right now I'm just going to delete these ones. Let's say I'm not sure whether I'm getting into one of these. I'm going to go ahead and inside of here, I can do a print. And in this case, this one is sometimes what I do just to be really quick with something. Sometimes I don't even write words because I'm in a hurry. But I could write something in here somewhat informative and say, in the first if. So let's say I'm not sure where I'm at in my code. I end up with having, let's say, dozens of scopes, and things aren't working the way that I think, and I click this button, I'm saying, I'm pretty sure I'm in here, but I'm not sure whether it's actually happening. I can put this in here, and this will never ever print unless it gets inside this scope. And it's never going to get this to this line in this scope if it hasn't first done this line and this line. So this right here, if this prints, I know that this has happened. And if it doesn't print this, then I know I haven't gotten into this scope. Now, I haven't debugged this yet to make sure everything else in this circuit's right, so we'll see what happens. So the simulator's running, but nothing's happening yet. So what happens when I click here? Nothing. And when I click here, there we go. And it's not printing very nice. I didn't do the print ln, but this is telling me what happens. In this case, this is in the first if statement. Now, one thing I've noticed here is that both these LEDs are supposed to be on, but I'm not seeing this one on. So there's something happening here with my circuit to where it's not set up right. So what I could do is I could look back later and say, oh, I actually see it. I did put this resistor on, but you'll see that this line here hasn't been grounded out yet. So I found an error. There we go. Let's go ahead and start the simulation again. Oh, I should open my code so we can see what's happening. Oh, now both of them are on. So I found an error in here, and I knew that it wasn't my button because I was getting good button data. Then I knew I was getting into here, which meant instead of having to look through my whole code to see if something was wrong, I just had to look at these 2 lines. Yes, technically a third line, but just these 2 lines are the main things, and I knew these were right. I looked at them, I knew they were right, I didn't misspell anything, I didn't get this variable hasn't been declared yet or anything like that. So I knew I had to work. I knew that I had this set as an output, which meant I had to look over here. It wasn't my button, it wasn't my code, it had to be on this side, and now it is. So how come this one turned off and this one turned on? That would be later in my code when I tell my blue to turn off. If I click again, it'll turn on, and you'll see that my serial monitor runs again. My serial monitor stops when I lift up, my blue turns off. So prints are a very powerful thing. I really want you to start using them. Put them in every code just about. It's a great way to debug things and figure out what's happening.